This video we're going to prove the following lemma. For all a, little a and g, the set HA is identically the same as the set of all x's and g's such that a is congruent to x mod h. I'll modify that a little bit. Before I get into the proof, as always, I want to ask you nice folks to consider subscribing to my channel, especially if you like watching mathematical proofs, as that's all we do here. Okay, so couple of things. This set right here is the same as the following. This set right here, come on, is the same as the set of all x's and g's such that, well, the definition of this means that AX inverse is in H. So basically we want to show that H sub A, H little a equals that set. And to make life a little bit easier, I'm going to give a name to this set. It's A with square brackets. That way I don't have to keep writing this out. Now, when two sets are equal, if set A equals set B, what that means is that A is a subset of B and B is a subset of A. If you can show those two properties, then you can conclude that the two sets are in fact equal. Okay, how about we get into the proof? Maybe we'll start it a little bit lower. So like I said, we have to show that one set is a subset of the other. So right now, I'm going to show that H sub A, HA is a subset of A in brackets. So we let something be in HA. Let X be in HA. That implies that X A inverse is in H. But that also implies that the inverse of X A inverse, which is a X inverse, is in H. But this statement is the same as, well, we kind of have it right here. But it's the same as A being congruent to mod H. That implies that X is in A brackets. Now we show it the other way. We want to, okay, so let me make one last statement. So this implies that HA, I guess I don't need the brackets. This implies that HA is the subset of A in brackets. Because I started out with X being in HA, and I concluded with X being in A brackets. Okay, so now we're going to show that everything in A brackets is in HA. So let X be in A brackets. Now, for X to be in here, AX inverse must be in H. That implies that AX inverse is in H. Okay, but that implies that since H is a group, subgroup, its inverse is in H. But the inverse is X A inverse. That's in H. Now, if I multiply on the right of both sides by A, what I get is, well, let's write it underneath. Using their associative law, I get this is, I should say, is an element of HA, and this is E. So XE is an element of HA, and X is an element of HA. Well, if X started in here and we concluded that X is in AH, what we have is that A in brackets is the subset of HA. Now, combining these two, let's call this star and double star, combining star and double star, we have that HA is in fact equal to A. That's what I wanted to prove, and I did. If you like watching videos like this, subscribe to my channel, as this is what we do here. I prove lemmas and theorems and facts and corollaries. If that's what you're into, subscribe to my channel. Click the like button. Please leave a comment. See you guys in the next video. Thanks for watching, and never forget, watch and learn.